All right, hello everybody. Welcome. Thanks for coming late in the day on the last day of build. We definitely appreciate it. My name is Scott Spears. This is Andreas Wanquist.
Nope.
Always worried I'm not saying that right, but I think I got it right.
Nice.
We're here to talk about Simplygon and how Simplygon helped Remix, which is another internal Microsoft product, Remix 3D, become platform independent. And by platform independent, I mean be able to take their 3D assets and 3D objects and easily move them around between different use cases like HMDs, HoloLens, web use. So we will jump right in. So imagine you're working with a very complicated 3D asset, something like a very complex CAD file, a high poly model of manufacturing equipment, and the client wants to see an experience like this, where they can see it on their target platform and have a very smooth, good experience. It could be a mobile device, it could be HoloLens, it could be an mixed reality headset. So how are we going to get there? We've got a 3D object. We need to get it on platform. It can be very difficult now. It's very much a manual process often. Artists have to take time optimizing assets, which can take hours, days, weeks. If somebody's built a very high poly asset and you need to run it in real time, artists can spend a lot of time that they should be spending creating new assets and making the assets look amazing. They can spend that time instead optimizing those assets, and that's not really where you want them to spend that time. So Simplygon gives you a way to automate that process and automate the transcoding, which is moving between file formats, and the optimization of those assets to easily get them on the target platform you need to get them on. And all that while preserving the fidelity of the original object. So it's going to look as good as it did originally. Let's talk about transcoding first. So transcoding is converting from one file format to another, but they can be saved, 3D objects can be saved in many different types of file formats. Some of them don't use triangles, some of them use NURBS or splines. Different 3D modeling packages can build things in different ways, and you don't always have the software you need to do an elegant transformation between one to the other. And often artists, again, have to go in and manually touch up any mistakes that happen. You can lose textures, there can be holes in objects. It can be very difficult. So Simplygon can take in JT, STEP, FBX, OBJ, STL, GLTF, and GLB file formats. These are most of the, or a lot of the 3D file formats that you're going to find. It includes a couple of CAD formats that are very popular. Transcoding CAD files especially can be touchy and difficult because of the sensitive nature of how they're built, and they're not really built for visualization in the first place. They're built for building things eventually. We output to FBX, OBJ, STL, GLTF, GLB, and SSF, which are most of the formats you're going to find for any engine. You're going to be looking at these objects in 3D, in real time, and on most devices that you're going to be looking at them in. So optimization, let's have a look at that next. So CPU and GPU power are always limited, depending on the machine, obviously. There's a huge range, but even on a powerful PC, you're always going to come up against limits. And our job is to make sure that you don't hit those limits in a way that the viewer can see. In a real-time environment, you need very, very efficient assets, especially as you throw in, a lot of the examples you see one asset. Often you can be dealing with a group of assets. The more you add to the experience, the more you add animation, AI, things moving around, you're going to need more optimization to have that be a smooth experience. So you need to look at it holistically. So there's a number of triangles, there's a number of objects that make up an object, shader performance, and the way to really get rid of those bottlenecks is to consider all these things and have a holistic approach to optimization, which is what Simplygon does. It looks at all of these factors and the original visual fidelity of the object and does whatever it can to preserve that. So it can automatically reduce triangles. When you make the triangles larger, it makes shader optimization better. The shaders will run faster. And again, it's going to really preserve that look of the original object when the shaders are working well. So the next step would be getting it through to the app and the engine. So we support all the major 3D engines, letting you get your content on the device with business standard engines and tools. So no matter, again, mobile, headsets, HoloLens, you're going to be able to get your content where you need it to be. So we've talked a little bit about why you need optimization. Now let's have a look at what optimization actually does. So here we have a couple of horse skeletons. We didn't optimize them by removing the outside of the horse. They actually came this way in the first place. And although they look identical, the one on the right is significantly more optimized and efficient than the one on the left. And I apologize for the projector bounce. It's not our video. It's the projector in the back reacting to the building moving constantly. So when we overlay the wireframe on the two models, you can see the density difference between the two. The other one is almost black because there's so many triangles. And once we've optimized it, there are far, far fewer triangles. And if we look at the actual numbers, we went from 4.5 million triangles to 18,000 triangles, which is significantly reduced. And if you notice at the beginning, you really couldn't tell the difference between those two assets. So another way to think of optimization is JPEG. So if you're on Photoshop and you've got a PSD, you can't really open that PSD on any piece of software. It's significantly larger than a JPEG file. So if you're going to display that anywhere, you convert it to a JPEG. You crunch it down, you get rid of the layers, you lose some depth and some quality, but what you trade that off for is being able to have it compatible with across a massive number of devices and file formats, and that compatibility and that portability. So we do very much the same thing with 3D assets. Kind of the JPEG of 3D, we sacrifice depth for compatibility and performance. So you might lose some of the ability to go in and preserve the hierarchy of an object, take it apart and put it back together. You can do that, but it's a little less of an automated process. But you end up with something that's so much more efficient than what you started with, and compatible across a range of devices. And as you can see, visual quality loss is minimized as much as possible. So let's talk a little bit about pipelines. So Simplygon is going to be a part of your art asset pipeline. I come from a gaming background where we lived art integration and art asset pipelines, and they're not an easy thing. And as people move into the MR space, it can be difficult to understand how art integration works, how easy it is to break, and how difficult it can be to get good results on the other side, especially when you're dealing with something that has to run at 90 frames per second and up to get a good experience. I used to work in sports games for an unnamed company, but we would deal with thousands upon thousands of assets. And when I first started, we had to manually optimize all those assets. And it would take weeks of artist time, and we would sacrifice creating even more nice assets to create all these LODs so that we could run the game. If we had had something like Simplygon as part of our pipeline, it would have made an amazing difference. And today, 80% of AAA games use Simplygon in their pipelines because they understand that to run in real time, most of it wouldn't even be possible based on the assets that they produce. As games become more realistic, as you're going to throw something on an Xbox, it still needs to be heavily optimized to run well. And the Coalition, for example, for Gears of War uses Simplygon in its pipeline as it puts its assets through. They're automatically optimized on the way into the game engine, and their artists don't even have to think about the optimization step. And in that hero asset is preserved as well. So if somebody asks for a change, all you have to do is go back and change the original asset, and that cascades through that process, and you end up with an updated, optimized asset that goes into the engine. So we'll look at how Simplygon can fit into an existing art asset pipeline. So you've got source assets that maybe look like a bunny rabbit. You can have scans, Maya files, 3DS, CAD files. You've got a pipeline set up. And what you're going to do, and what we're talking about today, is our Azure Marketplace offering. So you're going to upload your asset to your Azure Blob storage. You're going to ask for the asset to be processed, track the progress. It's going to be sent to our cloud offering. We will process the assets magically and send them back to Azure Blob storage, where you'll pull them down again, and then they will go into the rest of your asset pipeline. And they will come out the other side, optimized for Unreal, Unity, WebGL, really whatever real-time engine you happen to be using. we output a file format that will work in that engine. So we're using Simplygon. So the core, and I'll get into a little bit of how it actually works and how the processors work. So you don't address the core directly. You address it through the REST API that's exposed, and that will use our Simplygon processing language, which will tell it how. It's basically a recipe for how you optimize those objects. So you figure out what kind of optimization you want to do. You will feed that SPL in with the object, and it will optimize it for you. And some of the processes that we handle are reduction. So that's simply reducing the number of triangles in a piece of 3D geometry. Remeshing, which actually rebuilds the geometry from scratch, and you get an entirely new object that is highly optimized. All the textures and materials are packaged up and reprojected onto the model, so it virtually looks like the original model. Aggregation, so another aspect beyond triangles is draw calls. So often draw calls are being sent from the CPU to the GPU whenever you have to draw an object on screen. The more draw calls, the slower that process is, and it begins to slow the whole system down. Aggregation takes, you could have an object, a city, for example, made up of hundreds of draw calls. We can combine those into a single object, again, combine the materials, and have only a single draw call for that object. And material baking, which really happens across all of these processes. It's the bit that packages up the multiple materials, all the texture maps, normal maps, preserves all that, optimizes it if necessary, and gives you something that looks very much like, or exactly, really, depending on screen size, the original object. And you specify all these operations in an SPL file. So the SPL files control the behavior of the processors with setting files. And in a simple illustration of how that works, you've got the source asset, the SPL, that's what goes into the cloud. And that's what results in your optimized asset, depending on what that recipe is. So using a real example, we've got a scanned head that was 14 million triangles, and that's a chunk of the SPL, so that's what it actually looks like. It's gone into Simplygon, and it's been remeshed and come out the other side at 3,220 triangles. And you can see, even on this PowerPoint, the difference between the two assets is minuscule. And when something's moving on screen, again, people aren't looking super close. Unless you really study it, you're not going to see the difference. And on the target platform, getting the appropriate amount of detail for the target platform is important, and that's where you can really gain the optimizations. So Simplygon Cloud is our Azure Marketplace offering, and there's use cases that it's a little better at right now. It can still do pretty much everything, but some of them are a little smoother than others. If you have a catalog of fairly simple assets that are all fairly simple or fairly similar, it's going to be a faster process because you can use the same SPL files to process everything. So you can process a massive, if you have a large library of assets. This is a good way to put those things through. Outside in use cases, so if you're looking at like the picture of the engine I had up earlier, the horse skeleton, something that's looked at from the outside as opposed to an environment. If you have to fly through an environment or go inside of an object, it's a little bit more difficult to handle. Triangle count, if it's the major bottleneck, it's a really good use case because it's very easy for us to do the decimation. That's a piece that's very, very trivial for Simplygon. So again, where only the exterior of the model is to be visualized, that's an ideal use case for us. Asset catalogs with standardized materials. So if you have a library of consistent materials, that's much easier for an SPL to handle. And some hardware use cases, they're all doable. It just takes a little bit more setup and a little bit more figuring out upfront how to approach the SPLs. But environments, so when you have to fly through an environment and you need to preserve the interior of an object, often you have to take it apart, optimize assets, and put it back together. So assets that can't use a single SPL file for the entire asset, if you have to, again, take it apart, apply different SPLs, and then put it back together, it's a little bit more work, but you can still get there and have a very optimized asset in the end. Assets with special configurability needs, you'll often have to deal with that after the processing has happened. Really complex materials or wide material libraries with very differing sets of materials, the more consistent they are, the easier it is to process. Problematic geometry. So we can do small geometry repairs, but it's not really a big piece of what Simplygon does. So the more that your geometry is good and clean going into the system, the better results you're going to have. And that's a common garbage in, garbage out kind of mantra that most software packages adhere to. So again, these are all doable, but they just require a little bit more effort up front. And actually, we need to flip to the video. So a lot of you may have seen these running at the booth, but I think they're worth looking at again as to show really how far we can go with the optimization and how little visual fidelity is lost. So we're going here from 14 million triangles and a 1.2 gigabyte head. We went to something like 2,000 triangles on that one. 127,000 triangles to 11,000 triangles. You can see small differences when we zoom in, but in most cases, it's really hard to spot any difference between the two assets. And we're getting it down to 8% of the original size. In some of them, it's far more than that. And you can see how we changed the layout of the triangles. That's going to help the shaders display more efficiently. In this one, you can see we took the draw calls down from 72 to 8 draw calls, and it's 5% of the original size. Again, that's all going to translate to a much more efficient asset when you're trying to visualize it. 4.5 million triangles down to 10,000 in this one, so from 708 to 2 megabytes. And again, you can see the difference in just the density of the triangles visually without the count. It almost becomes a solid object when you look at the triangles. And back to the scanned head. So 14 million triangles. This first one went to 14,000. And you can see all the nice normal maps and all the lighting, the way it takes the lighting is preserved. And this one vastly reduced down to 2,000 triangles. That could run on your phone, virtually anywhere. So these days when you see a lot of assets being moved around to different places, I'll use that gaming example again. You can see a game appear on PC, on console, but now you also often see the same game appear on your cell phone. A lot of that is because they can take these assets, and most of these companies are using Simplygon to run their assets through and get something that's highly, highly optimized and efficient so it can run on those mobile devices. And now I will turn it over to Andreas to go into a little more detail about how you can really hook the cloud offering into your existing or being built asset pipelines.
Thanks, Scott. Do you have a clicker?
It's right there.
Thank you. So the Remix pipeline. What is Remix 3D? Let's do some gymnastics so you wake up, okay? Have you heard about Remix 3D? Right hand up. Oh, keep it up, keep it up. We're not done. Anyone has opened Remix 3D? Left hand? Awesome, good, nice. So this is the quote from the launch blog post. It says Remix 3D is a hub for connecting with content and creators, including over 1 million 3D objects and models that you can repurpose for your own creations. So it's basically a portal for 3D content where you can upload your own and also use what's there. You can create collections to handle your favorites. And you can also take what's there and combine and remix, I think that's where the name comes from, into your own creations. So how come Remix needs a content pipeline? So they got loads of assets that they want to display, and they want a smooth experience in the portal, of course. But they also want to be able for people to use their assets on different platforms. So this means that they need the content pipeline to run the assets through with possibilities of different optimizations for different target platforms. So the premise is they got a huge asset count. It's being added new models daily, of course. It's community driven, so people are creating and remixing, and every time someone is using the most complex asset, remixing that with something else, well, there's an even more complex asset. And also there's curated content that Microsoft uploads continuously, which is of very high poly count sometimes. And the goal, smooth experience for the content portal, of course. Also, they want you to be able to download the content and use on different platforms, like, for example, or not example, exactly, the web, mobile, HoloLens, and immersive headsets. Plus, we also create something that we call Preview Proxy, that's basically a thumbnail, but in 3D. And to do this in a good way, we need to find optimal settings, which isn't really clear from the get-go when you have over 1 million assets. So there's some iterations needed, of course. This means that we need to be able to like burst through the entire content every now and again. Here you can see an example. This is my own personal unicorn collection on Remix 3D. And as you can see on the right, there's quite a bit of a difference. I think the top right guy is actually the bottom left one, created by or uploaded by Microsoft first, but someone remixed that, made him into a DJ, on with the headphones, gave him a turntable, some speakers, and he's good to go, right? Whereas the guy just below him, that's someone using primitives, but just getting their inner love for unicorns into bits and pieces right on the computer screen. Super elegant. But it very much shows you how the content can differ. So, what does the pipeline look like if we're talking some Azure parts here? It all starts with a new model is being uploaded into the content portal. It's being stored in a storage account. Then we run some logic at first to decide if are we going to do something with this asset or not, because if it's really small, then there's no real use. So I think we have a breakpoint for 5,000 triangles. Any platform can basically render that, so then we don't do anything. And turns out that there's many users that tries it out, just creates a plane, and then, I don't know, the dinner is ready, they run off, and then we have a plane, and we can't really do that much with 2 triangles, right? There we go. Then we call the web API with the information about the job. That is then going to be persisted in the database and then put on a job queue. After a while, that gets picked up by a machine running Simplygon, which then goes to the database, fetches the information about the job. Then the processing will start, and we'll get the asset from the storage account and process that and put it back. At the same time, information is collected by application insights, which we then surface in Power BI to create dashboards so that our team and the Remix 3D team can have full insight into how the system is performing at all the time. And then you're able to get your nice finished assets from the Remix portal, or use it in immersive headset or HoloLens, for example. So now you're all thinking, this sounds awesome. Can I do this as well? And yes, you can. So we have, as Scott said, an offering on the marketplace that we call Simplygon Cloud. So if you go into the Azure portal, just search for Simplygon and select Simplygon Cloud. Fill in some basic information that's needed to create the VM. And you get to select the size, push create, and then you're done. So what happens then is that we will create a couple of artifacts in your subscription. The main players are web app for an API, database and a VM. Then you also need to create a storage account to host your SPL files that my colleague was talking about, and hold your assets, the ones you want to optimize, as well as the optimized result will be held in storage. So when this is set up, it's really easy to get working with. Just store your asset, and then you call the API with either HTTP or a C# SDK that we have for your convenience. After that, excuse me, the job information will be stored in the database, and then Simplygon machine will pick it up, fetch the asset, start the processing, update the information about the job at all times so that you can fetch information at all times from the API. Then, when it's all done, it's going to put the asset back. Then you'll be able to fix or fetch the result from the storage account. Demo time. Let's first look at the setup of this. So at first I was thinking I should use the C# SDK for this, but we got some examples for that will get you going really quick. So I thought that I'd try to dip this demo in some of that serverless magic that the Azure Functions team is going on. So the setup looks as follows. There is a function app, and there's a Simplygon cloud, and I also have that storage account, which I was talking about before. So when you insert the asset in the storage account, there's a function that's listening to that. And then that will trigger and call the API. And then the API will insert the job information in the database. And the Simplygon machine will pick up the job, get the asset, process it, put the information about it in the database at all time. The API can be later queried by another function, a daemon function that's running and just outputting information about the jobs. So, time to show some code. So, there we go. Thanks, Scott.
No problem.
So this is the Azure portal. I got my storage account set up and the function app. We can first look at the storage account. So here I have a container where I store my SPL file. And as you might remember, Scott said that's kind of the recipe that we're using to optimize the asset. I have a container for already processed blobs or assets. Then I have one where I insert those that's supposed to be reduced. So I have an old one here, I can remove that. There we go. And here's the code. So this is just the daemon app I was talking about. Every minute it just logs the information about whatever jobs is going through the system. Nothing much, we'll see that in action soon. Here's the blob trigger function. It's listening to the container named asset reduce 50 that I showed you. So I kind of tied this to the assumption that everything that's going to be put in that container is something that I'm going to reduce and remove 50% of all triangles in. And that is just creating a Simplygon instance, which calls that reduce 50 async function. We can have a check at that. So that will just basically get the name of the asset that we stored. It will create something that we call model, or simple model in this case. This will be used to create an asset. If the asset is created, okay, then we create a new job with information about that. And we also use an SPL ID here. And this is kind of cheating, it's pre-baked, but I already stored that asset, so I have an ID for it in the database already. Assuming the job was created successfully, we're just going to call start on it. There. So let's see if that's working. Just upload an asset. Oops. There we go, and we're off to the races. Meanwhile, we can take a look at that SPL file we have been talking about as well. It's nothing magical, it's just a text file, it's like JSON based, but it's all the settings that you can use. So right now, I'm aiming for reducing the triangle count by 50%. And this is kind of all that's needed, although there's some more base settings, of course. We have examples for our C# SDK example, where you can get loads of different versions of this, so you can get the feel for what you can actually do. So meanwhile, take a look at the process container. We can see it actually outputted something here. And it was, oh, that's an old file. Let's see, maybe it's not done even. You check the function. Here we go. There's too many people using the internet today, apparently. So here we can see 2 minutes ago that the sneaker FBX file was uploaded. And the size is approximately 27 megabytes. If we go over and check the job status, we should see it at least being worked on, hopefully. Might even be done. Yes. So it says here, the job we created with the sneaker, the output was called sneaker reduce 50, or the input was, sorry, and that it has been completed. Check my storage account again. See if there's an actual file in there. And well, we have the file, and it's reduced to 3.5 megabytes approximately, from 27 megabytes. It's kind of hard to visualize that, so actually, thank you. So we're past that. So this is the result. On the left is the original, and as you can see with the mesh on it, the result is quite striking. It went from 27 megabytes, which is, it's not a lot, but still hard to load on some devices, down to 3-ish, which is a big reduction. But as you can see on the rendered shoes, it's really hard to see the difference. And this took about a minute to do. So more resources if you want to get going can be found on account.simplygon.com. We have the documentation for Simplygon Cloud, the API, and the C# SDK. There is also a download section where you can get the SDK and also the SDK examples. And as I said before, those are targeting different scenarios, so you will have quite a lot of different SPL files in there to help you along with the first couple of steps. And in closing, please come visit us and talk more in the expo, which closes in like 10 minutes, I guess. But I really hope that you have been there and talked to our other colleagues in the mixed reality area. I know we've had a great time talking to you, and we really want to say thank you for staying this late, going to the last talk. I know you got to be drained, everyone. It's been an honor speaking for you. So with that, thank you. Thanks. And if you want to make us just as happy as this little guy, then please fill out the evaluation forms. They're really good for us to get some feedback for next year. Oh, you win prizes. We need to go fill out, Scott.
We need to fill out our evaluation forms.
Exactly. So questions, if you have some. Well, excuse me, can you use the mic, you think?
Yep, thank you.
So going back to the process you are using within Remix 3D, so do you use one generic SPL file, or do you have several SPLs and you pick them based on some conditions? How does that work?
You can pretty much play it as you want, right? Were you asking for one asset or for different?
So is that process completely automatic, or is there a person who is actually checking the quality of the assets? So can you elaborate on the pipeline used for Remix a little bit?
Okay, your pipeline stuff's going on.
Pipeline stuff is me. So I believe what we did was come up with some common recipes for. We grouped assets as much as possible. So you've got certain types of assets, some that are more organic, some that are more hard surface models. And have targeted SPLs for those categories. We do some quality control and make sure that we're kicking back anything that isn't working properly. But we found that we can come up with recipes that cover a wide variety of different assets and different reductions that are needed to make them optimized.
Just a quick follow-up question.
Sure.
So do you have any plans on releasing kind of generic pipeline for everything?
For everything in the world?
I mean, so for instance, if I want to create a viewer on HoloLens, I would want to be able to upload anything basically, right? And I want to be able to see it in in a relatively good quality. And to make that process automatic, I won't be able to specify to pick a specific SPL. So I'd like to kind of upload the file and get a good file, whatever it is.
Yeah. I mean, our goal is to simplify as much as possible. We offer example SPLs so that you can just grab those and try them on assets that you have. We want to make it as simple as possible. The cloud offering is a little more in depth. You have to play with those SPLs and figure out what you want. Yeah. But you can get there, and you can get to a point where it's fairly automated.
Yeah.
So the best way to think of Simplygon right now is a part of that pipeline, and it's a part that you have to tune and play with. But once you hit sort of that sweet spot and you understand your assets, you can really optimize large numbers of assets and get good results.
Hi, how does the pricing work for the Simplygon Cloud? Is it you're just charged for the resources as something's running, or is it some instance that you're
So
turning
I can
on?
take that.
You can take it?
Yeah.
Excellent.
So as I showed you the instances that were created in your Simplygon, or in your, excuse me, in your subscription when you created Simplygon Cloud, the price point is very much tied to the VM. So if you turn that on and you burst through your, say you have a couple of assets and then you turn it off, then the pricing will be good or okay. I mean, because if you look at the price point when you start it, then it's based on the premise that you're doing 24/7 reduction, and you're probably not doing that. So the other things like the web app, the database, they don't cost that much. So if you can just toggle the VM when you're using it and not using it, that's going to be your key to have a successful economic situation using this.
Got it. Thank you. And I really liked the whole pipeline optimization pipeline you had there. Is there any chance you have like that code or those step-by-step instructions of how you did that somewhere online?
The one I demoed?
Yeah.
We have very similar and even a bit more advanced and easier things that we have in the C# SDK if you're used to using C#. I went a bit the other route and used HTTP to just call the API, right? So we have help classes and models for you all created in the C# SDK that will get you running even faster than this small demo code will.
Okay.
So it's available for download at download page.
All right. Thank you.
Thank you. Anyone else?
No one else. I had another one.
Oh,
Go right ahead.
please go.
We had tried some Simplygon. That works very well, though did have some trouble on, I think it was tiling textures or some meshes that didn't have UVs that we tried to proxy. Is there anything more in a sort of automated UV mapping within Simplygon? We eventually got around it by using like a product called Flatiron that was part of 3ds Max to kind of do some auto UVing and atlases, and then went to Simplygon after. But does Simplygon have any kind of offering like that?
I'm not sure about the best way. Were you using the client at all, the UI, or were you running things just with SPLs through?
How were we running it?
Yeah.
We were using actually what I think is now deprecated, Unity's Simplygon plugin that ran on a Simplygon grid instance running locally. And actually, I think we installed some Simplygon grids in Azure VMs before there was the Simplygon cloud.
One thing I often do to sort of troubleshoot when you have instances like that come up is use the Simplygon UI, which is part of Simplygon Connect, which is something you can download for free off of our website. Sort of exposes all the dials and knobs of the SPLs, and you can try different approaches when it comes to mapping and how it deals with the material baking, and try different options in there. I don't know specifically whether we can handle that specific case, but it's a good way to go in and try. Just sometimes it's just a matter of trial and error, as it is often with 3D packages, to get the best results. So I would try some different options and see what you get, and then that could be applied to the SPL that you then use when you're dealing with a lot of assets that are similar.
We added some capabilities for mending small holes.
We do.
Flip triangles, stuff like that.
Oh, for non-maniform geometry?
Yeah, but I'm not quite sure.
I'm not sure on the mapping side.
Exactly, and I'm not sure it's in the version that you're using.
Okay, probably not. I don't think so.
So you could look at that.
Yeah.
Excellent. Yeah, we need to update. Okay, cool. Thank you.
Thank you.
Thanks.
Yeah.
Anybody else?
Thanks, everyone. Hope you had an awesome build. And I hope to see you all during tonight's festivities. Thanks.
Thanks.